Good afternoon, everyone. Today we're going to do some algebra with some exponent laws thrown in there, and we're going to solve this kind of complicated looking equation using these two, most prominently, these two exponent laws. Okay, so let's go ahead and see how that plays out. So for our first term, we have 2 times -3, the base is -3 inside a bracket, all raised to the power of 3. And so we have 2 times -3 cubed means -3 times -3, being positive 9, times another -3, and so -27. Next we have 3 bracket 2x all squared. Now 2x is going to be an example of this exponent law playing out. So when we have 2 bases essentially as the product of one another, all raised to an exponent m, then we can attach the exponent m onto each part of the product. And so a times b to the power of m can be more simply written as a to the power of m times b to the power of m. And so the exponent can attach itself to each part of the product. And so if we have 2 times x all squared, then we can have the exponent of 2 attach itself to each part of the product. Okay, just like we see here. And so we'll have 3 bracket 2 squared times x squared. Okay, I'm writing that very explicitly so we can see this exponent law taking shape inside of our equation. And next we have 3 squared to the power of 2. Now we could evaluate that normally. We could evaluate 3 squared, which is 9, and then raise 9 to the power of 2 again. Or we can apply this exponent law that when we have a base a to the power of m, and all of that is raised to another power of n, then we can either switch the exponents, but in this case that won't help us, or we can write it as the base a to the power of the product of the 2 exponents at play. So m and n can also be written as the product of one another. And so 3 to the power of 2 to the power of 2 can be written as 3 to the power of 2 times 2 to bring the exponents together into one exponent with a base of 3. Okay, the brackets are redundant at this point, but just to keep the same shape for the equation, I'll leave them in. And we still have our equations for 7. So now let's simplify one step further. This equation, this equal sign is not necessary. Now we can use PEDMAS, or BEDMAS I should say, we use teaching French. 2 times -27 gives us -54 plus, now we have 3 bracket, 2 squared is 4, x squared is x squared, and so next time whenever you see something like 2x all squared, you can think, well, the square just attaches itself to each part, and so 2 squared is 4, x squared is x squared, and so 4x squared, okay? As you get more practice, that'll become automatic. And next we have minus 3 to the power of 2 times 2, which means 3 to the power of 4. Right? Whenever you have a power to a bigger power, you can always just combine the exponents by multiplying them. And so 3 to the power of 2 to the power of 2 becomes 3 to the power of 2 times 2, which is simply 3 to the power of 4. Okay, that should save you some time as you go further along with the exponents. And so now we're almost getting to the solving part. We have -54 plus 3 times 4x squared means 12x squared, and then minus 3 to the power of 4, we can evaluate that. 3 to the power of 4 is 81, and now we have equals to 57. We're almost down to the end. We can combine our like terms because the first and last terms are constant terms, and so -54 minus 81 means -135, okay? And we still have our plus 12x squared, all being equal to 57, okay? Now we almost have a step 2 equation, except we have an x squared term here rather than just an x. And so let's isolate this term. Let's add 135 to get rid of the -135. Same thing on both sides. And so now we're at 12x squared is equal to the sum of 57 and 135 being 192. Okay? And now, of course, we divide by 12. We divide by 12. And so we get x squared is equal to the quotient of 192 and 12 being 16. And now we have to be careful with our very last step. We have x squared is equal to 16. When we take the square root of both sides, we must remind ourselves that a square root of 16 has 2 solutions, either positive or -4. Because we know that positive times a positive creates a positive, but also the product of 2 negative numbers also creates a positive product. And so if the square root of x squared is equal to the square root of 16, then x could be either positive or -4. And there's our solution. okay? And so I hope this kind of gave you an idea of the practicality of these two exponent rules, two very common exponent rules. I hope this gave you just a visual of how to solve a more complicated looking equation, and how if we just take our time to go through it step by step, it ends up being not so awful. So if you guys have any comments or future videos, please let me know. I hope this was helpful, and thanks for watching.